Hello, I'm Brian Farrell, and welcome to T's session on the Introduction to the DNS Service. Today we're going to be talking about DNS servers, DNS records, and we will conclude with a brief discussion on dynamic DNS. And with that, let's go ahead and begin this session. We're going to begin this session with a talk about DNS servers. Now, DNS is the process that maps human-friendly names, as in www.google.com, to their appropriate IP addresses. Without DNS, we would have to memorize all of the IP addresses that we wished to visit. Now, DNS stands for Domain Name System, and it's very structured in nature. If the local DNS server apparatus doesn't contain the needed record, it sends the request up the DNS chain until a positive response is received back. Now, this positive response gets passed back down to the original requester. Now, DNS does require that an FQDN, fully qualified domain name, is used in order for it to function properly. Now, an FQDN is the www.google.com. It's that naming convention right there. The www is the specific service that's being requested. The Google portion is the local domain that contains the specific service, and the com is the top level that contains the Google that contains the specific service. That is an FQDN. Now that we've got that covered, let's talk about the different levels of DNS servers. First off, there can be a local DNS server. This is the server on the local network that contains the hosts file that maps all of the FQDNs to their specific IP addresses in the local subdomain. It may be present or it may not be present. Then there are top-level domain servers, the TLD server. Now, these are the servers that contain the records for the top-level domains. Examples of top-level domains are .com, .org, .net, .edu, so on and so forth. Now, each of these servers contains all of their information for their respective domains, kind of. And what do I mean by kind of? Well, the TLD servers do delegate down to second-level servers their information. They do that to ease the load so that the TLD server is not overloaded. But the TLD server is the server that is responsible for maintaining the record. Then there's the root server. This is the server that contains all of the records for the TLD servers. So if you're looking for a TLD that is kind of unknown, you will actually go to the root server, which will then pass you onto the appropriate TLD. Then there are authoritative servers and non-authoritative servers. An authoritative DNS server is one that responds to a request, and that authoritative server has been specifically configured to contain the requested information. An authoritative response comes from a DNS server that actually holds the original record. So an authoritative response comes from the name server that's been specifically configured to contain that record. Then there are non-authoritative DNS servers. Now, a non-authoritative DNS server is one that responds to a request with DNS information that it received from another DNS server. A non-authoritative response is not a response from the official name server for the domain. Instead, it is a second or third-hand response that's given back to the requester. In most cases, when we send a DNS request, we get a non-authoritative response back. Now let's move on to the various DNS record types. The first record that we're going to talk about is the A record. Now, the A record maps host names, or FQDNs, to their respective IPv4 addresses. Closely associated with the A record is the AAAA record, or quadruple A record. This maps the FQDN to its respective IPv6 address. Then there's the CNAME record. Now this maps a canonical name, or alias, to a host name. What that means is that you can have edcc.edu be the same as edc.org without having to maintain two sites. The edcc.org can be the canonical name for edcc.edu. This works in part because of the pointer record, the PTR record. It's a pointer record that points out to DNS that there is a canonical name. And finally, we have the MS record. Now, this record maps to the email server that is specified for a specific domain. It is the record that determines how email travels from sender to recipient. And now let's move on to dynamic DNS. Now, dynamic DNS, or DDNS, permits lightweight and immediate updates to a local DNS database. This is very useful for when the FQDN, or hostname, remains the same, but the IP address is able to change on a regular basis. Dynamic DNS is implemented as an additional service to DNS, and it's implemented through DDNS updating. Now, this is a method of updating traditional name servers without the intervention of an administrator. So there's no manual editing or inputting of the configuration files required. A DDNS provider supplies software that will monitor the IP address of the referenced system. Once the IP address changes, the software sends an update to the proper DNS server. DDNS is useful for when access is needed to a domain whose IP address is being supplied dynamically by an ISP, or Internet Service Provider. That way the IP address can change, but people can still get to the service that they're looking for. Now that concludes this session on the introduction to the DNS service. We talked about DNS servers, we moved on to DNS records, and then we concluded with a very brief discussion about dynamic DNS. Introducing network address translation. Today we're going to be talking about the purpose of network address translation, and then we're going to discuss how network address translation works. And with that, let's go ahead and begin this discussion. Of course, we're going to begin by talking about the purpose of network address translation. Network address translation, or NAT, solves a very serious problem of how to route non-routable IP addresses. As a partial effort to conserve the IPv4 address space, the private IPv4 addressing spaces were developed. These address spaces were removed from the public IPv4 address space and made non-routable across public IPv4 networks. And this led to the problem. Being non-routable prevents that private IPv4 address from communicating with remote public networks. NAT very simply solves this problem. A router with NAT enabled will translate a private IP address into a routable public IP address. When the response returns to the router, it passes the response back to the device that requested it. So now that we've covered the purpose, let's talk about how network address translation works. And first off, we get to talk about the fact that there are two categories of NAT. First up is static NAT. With static NAT, each private IP address is assigned to a specific routable public IP address. This relationship is kept and maintained by the NAT-enabled router. When a device needs access outside of the local network, the router translates the local IP address to the assigned public IP address. And when the response comes back, the router will translate the public IP address back into a local one. Static NAT is not flexible and leads to some scalability issues. An individual routable IP address must be kept for every device that requires access outside of the local network. So as the network grows, you need to increase the amount of public IP addresses that are under your control. That gets kind of expensive and kind of complicated. They developed dynamic NAT to resolve some of that issue. With dynamic NAT, the NAT-enabled router dynamically assigns a routable IP address to devices from a pool of available IP addresses. When a device needs access outside of the local network, the router performs the NAT function. Only the public IP address comes from a reusable pool of public IP addresses. That private IP address is assigned the public IP address from the pool, and once outside access is stopped, the routable IP address goes back into the pool to be reused. As initially designed, dynamic NAT was more flexible than static NAT, but it still led to some scalability issues. As more network traffic required access to outside networks, the pool of available public IP addresses needs to increase, or outside access cannot be achieved. But thankfully, there is a solution to this. And that solution is called port address translation, or in Cisco terms, that would be NAT with PAT. PAT is a type of dynamic NAT that was developed to increase the scalability of network address translation. When a local network device requires access to a public network, the NAT-enabled router dynamically assigns the public IP address to the device with the addition of dynamically assigning a port number to the end of the public IP address. The router tracks the IP addresses and port numbers to ensure that network traffic is routed to and from the proper devices. PAT still requires a pool of public IP addresses, but the pool may only contain one public IP address, or it may contain several for a large private network. This is the preferred method of implementing network address translation for two reasons. First off, there's less public IP addresses that are required, and it makes it easier for an administrator to maintain. Now let's talk about NAT terminology, specifically about the types of addresses. And we begin with the inside local address, which is a private IP address on the local network. It is the private IP address assigned to a specific device. Then there's the inside global address, a public address referencing an inside device. The inside global address is the public IP address assigned to the inside device by the NAT-enabled router, allowing access outside of the network. Then there's the outside global address, which is a public IP address referencing an outside device. It is the public IP address assigned to a device outside of the local network. Then there's the outside local address, which is a private IP address assigned to an outside device. This is the private IP address assigned to the outside device by the NAT-enabled router on the interior of the local network, so that the inside device can communicate correctly with the outside device. Now that concludes this session on introducing network address translation. We talked about the purpose of network address translation, and then we talked about how network address translation works.